3D asset creation and generation is the process of developing geometries and materials for 3D experiences. It has direct applications across several industries such as gaming, movies, fashion, as well as virtual reality applications. Traditionally, simulation ready garments are hard to obtain and are created through a laborious, time consuming process requiring specialized software which relies on experienced artists. Currently, creating virtual clothing for simulation is a challenging task. Garments need to be manually designed and draped onto an underlying body. Also, the topology of garments need to take simulation into consideration in order to enable pleasing results. In my humble opinion, low friction asset creation will be the key enabler in the future to unlock virtual applications at scale. Generative AI will be cornerstone technology that will allow anyone ranging from beginner users to experts to create customized avatars and contribute to building personalized virtual experiences. I'm also sure that it is going to assist in the design process to facilitate faster exploration and creation of new designs. That is where this new research project, Garment 3D Gen, comes into play. This creates 3D garments directly from image inputs, and let me show you a few of the examples as you can see on your screen. Now, if you look here, you can see that on the left hand side we have image input with the text that are light blue t-shirt with a flower, and then 3D texture garment has been produced, and there are a lot of other applications such as dressed 3D humans in motion, hand cloth interaction, sketch, and the list goes on and on. And on this bottom animated video you can see that there is also a virtual reality and interaction with the clothing. How good is that? Now this method, which is called as Garment3DGen, is performing topology preserving mesh based deformations to match the image guidance and synthesizes new 3D assets on the fly. Their generated garments comprise of posed geometries that stylistically match the input image and high resolution texture maps. The provided image guidance can be either from the real world or synthetically generated, which enables them to create both real and fantastical 3D garments. There are a lot of other examples which are scattered throughout their project paper, and I will drop the link to it in video's description. You can see we have dress to sketch, we have tank top to dress, t-shirt to armor, and lot of other stuff. Also, there are a lot of applications. For example, I just showed you hand garment interaction in VR, as you can see here. And if you look at it, what is happening here is that this garment 3D gen, which is a new method for synthesizing 3D garment assets from a base mesh using a single input image as guidance. This proposed approach enables users to create 3D textured clothes based on real or synthetic images, such as those produced by the text prompts. The resulting assets can be draped and simulated directly on human bodies. And that is basically what is enabling it to open up to many vistas. Leveraging recent advancements in image to 3D diffusion techniques, the researchers have generated 3D garment geometries. However, as these geometries cannot be directly used for downstream tasks, they treat them as pseudo ground truth and develop a mesh deformation optimization process to align a base template mesh with the generated 3D target. They have also introduced carefully crafted losses that allow the input based mesh to deform freely towards the desired target while maintaining mesh quality and topology suitable for simulation. Also, a texture estimation module generates high fidelity texture maps that maintain global and local consistency, faithfully reflecting the input guidance for rendering the 3D assets. With Garment 3D Gen, users can now generate their desired textured 3D garments without requiring artist intervention. By providing a textual prompt describing the desired garment, they can generate simulation ready 3D asset. They demonstrate the effectiveness of Garments3DGen through quantitative and qualitative comparisons on various assets, both real and generated, and also present use case illustrating how simulation ready 3D garment can be generated, and you have already seen some of the examples in this video. Now, having said that, let me explain a bit its architecture. If you look at this architectural diagram, given an RGB image, they have first performed 3D reconstruction using single image to multi-view consistent image generation techniques. They have then used this output mesh as 3D pseudo ground truth to guide a mesh deformation process to deform an input mesh geometry to match the target. Their output geometries preserve the structure and topologies of the input geometry, and that contains holes in the neck, arm, waist area such as that they can be fit two bodies and are of good mesh quality to be physically simulated. And then finally they have generated high resolution UV texture maps that are faithful to the input image to obtain the final 3D game asset. So really impressive, I would say, research, because it is really gelling with the current day's requirement. Because I have done some of the videos on some of the tooling, but I still believe that this is the area which has a lot of potential. And if you go through this paper, they have also showcased several applications where the output geometries of Garments 3D Gen are used for physics-based cloth simulation and garment interaction in a VR environment, as well as going directly from a simple sketch image to a drivable 3D garment, which is truly and amazing in this sense. Now, before I close off, one thing I wanted to mention here is that their deformation based approach. That is the approach that takes a base mesh as input along with an image guidance and outputs a textured geometry that faithfully matches the input image while preserving the structure and topology of the input mesh. I think this is a key contribution because it stems from the utilization of novel diffusion based generative model to synthesize 3D pseudo ground truth. Now, there is a lot of other information scattered throughout this paper, but I'm not going to read it. So I will drop the link to it in video's description. Check it out. Let me know what do you think. If you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.